while I was uploading the previous video, I found a question from Yusuf. You asked, would it be wrong if you use the point on the line instead of the separate point? No, you can use either or. Both of them are points on the plane. Okay, thanks, Yusuf. All right, now let's continue with what we have started. So, what we are going to talk about it now. If we have two parallel planes, those are two parallel planes. So this is the normal vector n1 and this is the normal vector n2. So when can we say that the planes are parallel? Planes are parallel if n1 is parallel to n2. And that means n1 equal a scalar multiple of n2. Okay, parallel planes has parallel normal vectors. Parallel normal vectors means scalar multiples. So example for this, if I have x plus y plus z plus 5 equals 0 as the equation of this plane, and the other equation of this plane is 2x plus 2y plus 2z plus 7 equals 0. Here, then the normal vector 1 equals 2 times normal vector 2. That means these two planes are parallel. Okay? Alright, so parallel vectors means, parallel planes means the normal vectors are scalar multiples. This is the first thing. The second thing, coincident planes. Plane lie inside a plane. This happens when the whole equation is a multiple of the second equation. Actually, they are the same plane. So if I have an equation like this, x plus y plus z plus 1 equals 0, and the other equation is 2x plus 2y plus 2z plus 2 equals 0. The whole equation is multiplied by 2, so even d is a multiple, are multiples. That means these are coincident planes. The whole equation are multiple. Okay? Alright, so that's the difference between parallel planes and coincident plane. Because simply I can divide this by 2 and get the same equation, right? So this is coincident plane. Now, when we talk about normal planes, like planes that makes 90 degrees on each other, okay, in this case, this is the normal vector for this plane, and this is the normal vector of this plane. So n1 has to be perpendicular or normal to n2. That means n1 dot n2 has to equal 0. So if we want to show that these two planes are normal, are perpendicular to each other or normal to each other, we have to get n1 and do the dot product with n2 and make it equal 0, or see if it equals 0. If it equals 0, yes, these two planes are normal to each other. Okay? So normal plane has two normal vectors that are perpendicular to each other. The dot product equals 0. Okay? Now, the angle between planes is the angle between their normal vectors. So if I want to find the angle between plane 1 and plane 2, I need to find the angle between their normal vector. How we do that? We use cosine theta, which is the angle between the normal vectors, which is the angle between the planes, is n1 dot n2 over the magnitude of n1 times the magnitude of n2. Okay, the angle between planes is also the angle between their normal vectors. So this is the angle between the plane. It is the angle between their normal vectors. Normal and normal. Okay, so the angle between the two planes is the angle between their normal vectors, n1 and n2. Okay, so if I give you equation of two planes and I asked you to find the angle between them, so let's say I give you a plane x minus y plus 2z minus 5 equals 0, and another plane that is 3 negative 3x plus 2y minus z minus 1 equals 0. And I wanted you to find the equation of these two planes. So n1 will equal 1, negative 1, and 2. n2 will equal negative 3, 2, and negative 1. So cosine theta will be the dot product, so negative 3 minus 2 minus 2. I multiply and add negative 3 minus 2 minus 2 over the magnitude of the first one, so 1 squared, 1 and 4, so that's square root of 6, square root 9, 4, 13, 1, 14. So this will be negative 7 over square root of 6 times 14, which is 4 to 84. So negative 7. So theta equal cosine minus 1, negative 7 over square root of 84. So we can find the angle. So cosine minus 1, negative 7 divided by square root of 84, close the bracket, and hit enter. So the angle between these two planes is 139.8 degrees. Okay. Alright. So, or it's complement, or it's a supplement. Now I want to give you some examples, and you tell me what kind of planes are these. So if we have 2x minus 3y plus 5z minus 1 equals 0, and 6x minus 9y, or negative 6x plus 9y minus 15 plus 21 equals 0. What kind of planes are those? If you look at it, this is n1 equal to negative 3 and 5, n2 equal negative 6, 9, and negative 15. So I can say that n2 is negative 3 times vector n1 that means, and D are not -3 of D, so the normal vectors are scalar multiple. I can say that those two planes are parallel planes. Okay? What if I say the same thing, but 2x minus 3y plus 5x minus 1 equals 0, and the other one is -6x plus 9y minus 15 plus 3 equals 0. In this case, the whole equation is multiplied by -3, so in this case, those two planes are coincident, same plane. Okay, so this is what I want you to know about this lesson, and I will give you homework, and I will post this on SB, and stay focused. We still have important things to do. All right, have a wonderful